All right, so that is also arranged. Well, first of all, let me introduce what we're going to do today. So you already, well, probably you have been reading what the agenda is of this webinar. So I'll just repeat that for you. So it will be about basic KNX building functions. So light, switching and dimming, blinds, and I will also indeed include feedback. So I will specifically do that for switching, because feedback is, well, the principle applies of course for the others as well. So that's the same thing. So basically I will only show feedback for switching. While doing that, I will show you the programming mode of a device, how to reset the device via ETS, because we will need that, you will see that. ETS group monitor is also an interesting, let's say, aspect to that. And then, of course, all together with that, I will be using some well, flags that are by default not set in the devices of devices, and that well, which are these flags? They are listed here. So the I flag, the read on initialization, the R flag for reading values, and the update flag. So that is everything that I indeed will do here. I will use for that, well, obviously ETS, but I will also use a software. So a software that will, how to say, virtualize or simulate, if you want, real KNX devices. So they are not real, but they behave like real ones. And that software is called KNX Virtual. KNX Virtual is already accessible to you, in case you didn't know that yet, in case you didn't found that yet. Well, in order to show it to you, I just logged into my own my KNX account and just went into will go into the part shop. And then you can find that under software. And since, of course, in my profile, I am also a manufacturer, I have many products like EITT and others. So products that you might not see in your account, like Manufacture Tool here, also another example. And then eventually you will land up here in KNX Virtual. So there is a description of that, a link, a video, a YouTube, all kinds of information there. But that is, of course, only for the current released version, which is the version 1.0. What I will show here is, what I will use is KNX Virtual 2.0. That is a software, this version will be released on June 24, so the next coming month. So you basically can witness here indeed, or you can have here a sneak preview if you want of that version already. So, okay, I basically think I can start with the actual webinar there, with the actual demonstration. So therefore, I'll just start the software. This is the software. So how to use that software? Well, first of all, this is ETS. So I'll just need to set the settings accordingly, so that I have via the settings I can set the let's say the connection between KNX Virtual and ETS. So that is in most of the cases you can accept just the default settings here, unless, example, given one another individual address for the IP interface because you want to use another line. In my example, I will just keep it simple. I'll be using the line 1.1. That means, and the address 250. So basically it means that I cannot use for one of the devices this address, right? That's the only limitation, I would say, or that's the only thing that you need to keep in mind. So I'll be using 11.250 as individual address for the interface between ETS and this virtual installation. So I just accept, and then we are ready to go. Good. First, maybe indeed explaining you how this software then indeed works. I mean, what kind of functionality is on board. Maybe I'll show you first the devices. This is a collection of devices, so you can see here 13 devices actually, including the interface as such, which already has the 11.250 individual address. And then what's there else? So I use the abbreviations here called DA, that's the dimming actuator. There's a blinds actuator, a push button, a room temperature controller, an HVAC controller, switching actuator, an alarm module. MPD stands for movement and presence detection, a binary input, a weather module, also a scene module, and a logic module. So too many devices to talk about, to mention even here today. So basically, for this webinar, I will only use the push button, the switching actuator, the dimming actuator, and the blinds actuator. So as I have prepared them here, indeed, in the ETS project, right? Based on these devices, I'll also have set up different views. So there's the base view. That means that you can use these buttons in order to operate lamps, dimmable lamps, and blinds. For specific things like, for switching, I include then other devices that can have an influence on lamps, that is movement and presence detection, the alarm module, binary inputs, and the same for dimming, basically. So that would be similar. Then some specific devices that can have influence on blinds, like the weather module. That could be a nice exercise to do as well, which I will not do here today. That could be for another webinar in the next coming weeks, where I will show that. Then there's also HVAC. Also not for today, just showing you how it looks like in the software. So there's a room temperature controller in order to control indeed the temperature in this room, and then devices that could have influence on that. So like outside temperature, obviously, and some binary inputs for a window contact. And what's furthermore? Well, that's it. That is just showing you the software. So I'll be working actually basically in the base view, and what we see here. So first function that I will demonstrate to you is the switching function. So let's start with that. So I just make that smaller so that both applications fit into one screen, but because I will only be using channel 1 of the lamps here, or channel 1 of the dimmable lamps, and also channel 1 of the blinds. So I can just make this smaller, just like this would be fine. And then, as I said, they both fit on in one screen. Okay, so the switching function. So therefore, the principle, as it is always in KNX, is just about linking so-called objects or communication objects from devices together. So in this case, yes, I obviously need an object or objects from the push button that need to be linked to the objects from the switching actuator. So I will, in both cases, use channel 1. So for the switching actuator, well, that is then this lamp. And for the push button, that's just the top row here, the first two buttons, if you want. They are respectively represented by channel 1. So I just select those channels, and then we have this overview here. So there's the switching on-off of the push button, and there's the switching, also on-off, of course, from the actuator. So the only thing that we need to do is to link these objects together, and then we have first basic function, right? So how do you do that? Well, my preferred way, or the way I always work, there are other ways of doing that with ETS. This is just one way, is to select both objects and then to use the context menu, use the menu link, and then indeed to add a new group address, because I have deleted all group addresses before, made sure that there were no group addresses here. So I can start again from just one, right? And I just confirm that. And then you see that indeed both objects are now linked to the group address 001. Well, obviously, that's not enough. I, of course, need to program the devices, and I intentionally going to start with the switching actuator. So not with the push button yet. Intentionally, you will see in a minute why I'm doing it in that way. So the first thing that I need to do is to program the switching actuator. Well, since this is a completely new installation, so where all devices have the default value for the individual address, which is, by the way, 15.15.255, I need to also change that. So in order to change that, that means that I actually have to do a full download for that device. After the full download, if I have to make modifications, I can choose actually partial download. Right? If I would already have the individual address program, I could also have chosen download application. Yeah? But now I need to do a full download. So let's do that. ETS will then do the necessary. It asks me or commands me to, well, it actually is a request. Please press programming button, it says. So let's do that. Therefore, I need to go back to the devices view and put the device in programming mode that actually indeed represents here the switching actuator, which is this device here, and this is its programming button. So I'll click that, and then it is lit, so it's red now. And after the individual address is set, the programming button is switched back to to the off state. And then actually I'm already in a position where I can do a first test, and that is via diagnostics, so via the monitor, the group monitor. So I just go back to the base view, and then you will see, I'll make the software a bit smaller again. If I start the monitor, and if I select via this button the group address 001, yeah, then I can already do a first test. Just a moment, please. Yeah. So with this right button, I can then select the value, of course. I need to select the value what I want. Off, well, it is already off. So in order to put the switch on, I select on. And then if I click the right button, I expect this lamp here to be switched on. So let's try. So this is indeed the case. So you can see here, this lamp is lit. The telegram that I have sent was on, and if I do another telegram with off, you will see in the monitor also that I will see a value off, and obviously the lamp will be switched off. So indeed, here we are. Congratulations, we have a first function in KNX. Although it's not complete, I wanted to have it operated via this push button. So indeed, one more thing to do is to, oh, yeah, sorry, I need to be here. Yeah, just doing the same thing. So also program this device, full download, exact same thing. And then via view, devices, I need to select the push button. Where is it? Here, this one, PB, push button, indeed. Put it in programming mode, and then just wait a bit. So let's go back to the base view, make it smaller again, and then see what happens. Yes, I am indeed able to switch on and off the lamp. And of course, at the same time, I can still, maybe I just clear the monitor. I can follow that also on the bus monitor. So you can see these bus operations. Yeah. So in the monitor, you can clearly see that the telegrams that I sent now came from the address 1.1.1, which is indeed the push button. If I would send it with the monitor, so if I do now value of write, then you can see that it indeed comes from the interface 11250. Okay, now let's extend this function because I'll need to have feedback for this as well. I want to see the result of my action of operating this push button. I want to see that also. I want to see that reflected somewhere as feedback. So how is that? How does that work? Well, first of all, in order to, so if we have a look again at channel 1 of both devices, then we will see that there is no other group address. There's only one object per device here. So obviously we are missing something, and that is always a clear indication. If you miss something, just go to the parameters of the device and add whatever is missing. So for the push button interface, I go to the parameter page, and there I can find out that indeed the functionality was set to switching no feedback. So if I change it to switching feedback and go back to the objects, I will see that for channel 1, indeed there is an additional object. For the switching actuator, same thing. So go to parameters and just select indeed the info on off for feedback. So here we go. And then if we do the same again, so we select both channels, then the only thing that we need to do in order to or maybe I just go one step back. So what we have done so far is we only control one aspect of the switching function. That is where we actually control the actual load. And now we're going to control the second aspect, that is where we control the feedback of that function. So that is actually information that comes from the actuator and goes into the push button. So, but it's always the same principle. Select the objects that are involved, link them via this menu. ETS automatically suggests 002 because I already have 001, so fine. And then the only thing that we need to do is to program the devices again. And as I have said before, a partial download is actually sufficient here, because the individual address is already programmed together with the application program. It was already done actually, so it's just updating actually. And the same for the push button, of course. Partial download, all right. And what we see then, maybe also clear the monitor at the same time. So what we then see if we manipulate the rockers again, is that indeed, so you see the color red indicates that the lamp is indeed switched on. Hope you can also see that clearly on your screen. If I switch it off, the color, the background color, so to say, goes back to black. So on, back to red, and so on. You can also see that in the monitor. So the first telegram, maybe I clear it again. Wait, first switch it off, maybe. Clear the monitor again, so that we can clearly follow this. So if I manipulate the rocker, I will see that indeed there's a telegram going from 1.1.1 to the bus with value on, and then there comes, so via group address 001, and then there is another telegram coming right after, so from 112, which is the switch actuator, that sends also on, but then on group address 002. So that is indeed the information about the feedback. Yeah. So example given, if I would now have a broken lamp, then I also expect that the actuator reacts accordingly. So on a broken lamp, I have simulated that by just clicking on the lamp itself, and that actually makes the lamp broken. So let's try that. So if I just click, then it says kaputt. That's the German word for broken. I thought it was funny to use a German word. So, but anyway, it means the lamp is indeed broken. And what I see is indeed that the device, so the actuator sends, so the 112 sends indeed on 002 off information. So like, yeah, there's no consumer here. There's no electrical consumer. So there's no light. So therefore I have to send, I have to update the status. And of course, the push button already immediately reflects that. So like, okay, the lamp is now switched off. So you can do whatever you want. Yeah, you will never see again red, unless I repair the lamp, which I just did now. Well, simulated, of course, and then indeed the feedback is back in order, right? Now, okay, let's go one step further, because what could happen in an installation is that for whatever reason the push button was, let's say, disconnected from the installation. There was maybe a power failure or whatsoever. And that could lead into indeed, let's say, in a situation where these push buttons actually don't, how to say, represent, or the feedback of these functions, of these buttons, don't reflect the reality, right? Because there are indeed actuators, so switching actuators and so on, that actually keep the values of their outputs, of their channels. They keep that information when there's a bus failure, bus reset, or when there's a voltage drop. So it could happen that indeed this push button doesn't reflect the reality on this lamp. I don't know if maybe I can try with a reset on the lamps. Don't know what the effect will be. Well, apparently here in this case, I have implemented it indeed in such a way that that a reset, so you can also follow the reset on the monitor, of course. So let me do that again. So if I do a reset, on device 112, which we can see here. So there is a restart command from 112. Then sorry, that came from the interface, but sent to 112. Then we will see that indeed this actuator actually has kept the information. If, however, we do that for the push button, so we do a reset here, we see here a command coming from the interface again to 1.1.1, but this time we see that yeah, apparently this information was not kept. And this is indeed typical behavior for push buttons, typical behavior for any visualization system, actually. So that's quite normal that this information is not kept. Yeah, it's not stored in the device when there's, example given, a voltage drop. How to overcome that situation? Well, therefore, we need to do something special, do something specific with the object, with the feedback object of the push button. So let's have a closer look at that. So that's the feedback object. So first of all, what we need to do is actually to set the read on init flag, right? Because we have seen now in the monitor when we do a reset of the push button that after the restart and after this command here, the T disconnect, there's nothing. There's no further telegram. And with this I flag, what you do actually here is you make sure that the device sends for this object a so-called read value. So it will try to get the value from somewhere. But okay, let's do it step by step. That means I'll going to do this this thing with the flag first. So the read on init flag, I'll just set it first. In order to set it, I of course need to program the device. And then we will see what the effect is of a reset after that. Again, I need to make it clear to you. Right now, we have seen that indeed, after the restart, there are no further telegrams. So I'll show you that maybe like this. So after restart, there was one more telegram, the T disconnect, but then nothing, right? We have seen that. Okay, then I made a modification in the feedback object. I have set the I flag. Here you can see that. Also here, this flag is now set, and I need to program it. So just a partial download. And then if I do, so I clear the monitor again because I was programming the device. If I do a reset, so monitor is empty, do a reset device, we will see there is indeed a group value read coming from 1.1.1 on group address 002, and then there is a group value read. But of course, a group value read as such is not enough because I need another object. The other object that is involved here needs to react, and I can only make it react by setting the so-called R flag. So what I'm saying is that I also have to look at yet the info on/off object from the actuator and put the R flag, because this is currently not happening. It's not set. It's not the case. So the read flag needs to be set as well, because that will make sure, with that flag, I will make sure that there will be a reaction from the device to this group value read. So, which we indeed clearly don't have right now. So next step, switching actuator. I'll program the device, just partial download. I clear the monitor again, so to have an initial situation. And then I'll, so empty, right? And then I do a reset of the push button again, reset. And then we will see that, yes, there's a group value read, and there's now a group value response coming from 112. And yes, so that is what I wanted. This is, however, not enough, because we will see when I switch on the lamp, yeah, and okay, I clear the monitor, and I do again a reset of the device. Then you will see, hey, this rocker or this feedback information is still not in order. Although I have indeed a read from the push button, there's even a response from, and even with the correct value on, from the switch actuator, and still it's not working. Yes, indeed, that's quite normal, because there's still one more thing missing, and that's the last step. That is, I also need to set the U flag. What is the U flag doing? Well, the U flag, with the U flag, I actually just make sure that the value of the object will be updated because of this response, right? Because in regular cases, like example given this one, so group value right, That's actually, these are the telegrams that typically are sent by push buttons. In order to react to the group value, or in order to react, this is a good way to express it. In order to react to group value write telegrams, I need to set the W flag, which is already set. So that's why the device indeed reacts. But in order to react to a group value response, I'll also need to set the U flag, the update flag. So that's yet another flag. And then the story is complete. So I'll just program the device again. Not a reset, but a download, partial download. All right. And then if I clear the monitor again, we will see now that if I do a reset of the, so I just switch on, off and on again. And of course I have telegrams in the monitor, but okay, that's fine. And then I do a reset. And then we will see that this time, yes, we do have the feedback as I wanted. So let's have a look at the monitor. So there was indeed the restart. So the interface gave a command to the device 1.1.1, the push button to restart. Then there was a group value read, group value response, to which this time indeed the feedback object reacted. So now this function is properly implemented. I would say it was already okay, but it was just not fit for, let's say, the typical case of reset. And this is now then in order. Okay, I think that was enough for the for the switching. So we have it now complete with feedback. So again, I repeat myself. How did I do that? Well, first of all, you need to set up the specific link for controlling the load of the function, the specific link for the feedback. But on top of it, you would also need indeed to set the I flag for the push button in order to get the value from the actuator. You can only get the value from the actuator if there also for the actuator, for the specific object, of course, also the R flag is set. And then on top of it, you also need to make sure that the update flag is also set for the push button. Otherwise, the group value response telegram has no effect. Okay,